The dreaded logarithm. What is it? Most sources will say, oh, the log is just the inverse of exponentiation. But what does that mean? Let's start with something simple. Suppose you want to solve this equation for y. To do this, we need to somehow undo the addition of 2. This is accomplished by subtracting 2 from both sides. So y is equal to 5/10. Subtraction undoes addition. In math language, we'd say that subtraction is the inverse of addition. Let's move up one level in complexity. How about this equation? 2 times y equals 512. To solve for y, we divide both sides by 2. The division by 2 undoes the multiplication by 2. In other words, division is the inverse of multiplication. Let's move up another level of complexity. Suppose we want to find a positive number y that solves this equation. Now we need square roots. The positive square root of 512 is about 22.63. The square root undoes the squaring. They are inverse operations. Finally, we get to this equation. The variable y is up in the exponent. How do we undo this exponentiation and solve for y? That's where the log function comes from. If we take log base 2 of both sides, it undoes the exponentiation, and we can solve for y. Exponents are fairly straightforward, but the logarithm goes the other way. What exponent do I need on 2 in order to get 512? I'll talk more about logs in the newsletter. You can sign up to receive it on my website.